also find the impact. Clear, everyone?
Okay, ma'am.
Yes. Shall I move ahead? Clear? Any doubts? Now this next is the multiple linear regression. So when I have a two or more than two number of independent variable, then it is known as the multiple linear regression. Multiple linear regression analysis is essentially similar to the simple linear model, with the exception that multiple independent variables are used in the model. So it is just like a simple, but in multiple linear regression, we have a more number of independent variables. The mathematical representation of multiple linear regression is y is equal to a plus bx1 plus cx2 plus dx3. So here my y is my dependent variable, x1, x2, x3 or up to xn is my independent variable. A is again my intercept, b, c, d are the slope. Multiple linear regression follows the same condition as the simple linear model. However, since there are several independent variables in multiple linear analysis, there is another mandatory condition for the model, and that is the non-collinearity. Independent variables should show a minimum correlation with each other. If the independent variables are highly correlated with each other, it will be difficult to assess the true relationship between the dependent and the independent variable. Now, there is one more assumption that we have to fulfill, that is the multicollinearity. If we have a more number of independent variable and if exist, now what is the meaning of independent variable? Independent variable should be independent itself. But if there is a relationship between one independent variable to another independent variable, then there is an issue of multicollinearity. Understood? So we cannot
All
exactly
right,
predict
ma'am,
which.
I missed it out because of some unavoidable circumstance. So, would you mind please again repeating the
Okay.
non-collinearity effect?
Yes, yes, no problem. So multiple linear regression is similar to the simple linear regression. In simple linear regression, we have only one independent variable and second is independent variable. But in multiple linear regression, we have a more number of independent variable. Now, assumptions what we have checked in simple linear regression are all same, except we have to one more assumption is that is the non-collinearity or the multicollinearity. So what is this multicollinearity? The independent variables should be independent itself. If there is a relationship between the independent variables, then there is a issue of multicollinearity exist. If the independent variables are highly correlated with each other, it will be difficult to assess the true relationship between the dependent and independent variable. Understood? So independent variables should be independent. There is no relationship between those independent variable. If the relationship exists, then there is the issue of multicollinearity. So in that case, we have to remove the issue of multicollinearity. So the one more assumption is that there should be a non-collinearity between the independent variables. Understood, everyone?
Yes, yes, ma'am.
Okay. So by doing the example, you can understand, you can get the more clarity. Okay, so similar, I am taking another example, that is age, height, and weight. So I want to check there is a the height and weight is my independent variable and the age is my dependent variable. So the person's height and weight or the age is depend on height and weight or not. So is there any impact of age on height and weight or height and weight on age? Just a minute, I will close all other windows. So this is the data, the weight, the height, and the age. Okay, and in the data view, you can, we have only the 12 samples, just we have to understand that's why. So how can I compute the regression? How can I compute the regression analysis? I have to go to Analyze tab. From that, I have to move to Regression tab. Under Regression tab, we have a linear regression. What is my dependent variable? Weight, height, age. Which is my dependent variable? Hello? Hello, am I audible? Hello, participants, am I audible to you?
Yes, ma'am. Yes, ma'am. Audible.
Okay, okay. So in this case, which is our dependent variable?
Age, ma'am.
Yes. So age is my dependent. So I will transfer age from here to dependent variable. I want to check the weight and height. So weight and height is my independent variable. So I will move here. I'm simply calculating. I'm not taking any of the options. I will later tell you how can you find out the multicollinearity. Then click OK. So again, the similar kinds of the table, you can see here the model summary, the ANOVA and the coefficient table. Okay. Who will interpret these tables? Who will interpret this table? The model summary. What is the value which we require to interpret? The R value. The R value is 0.349, which means hello. The R value is 0.349, which means, is there any relationship between the dependent and independent variable? Yes or no?
Ma'am, can you repeat it again? I have lost my network
No problem.
connection.
So what is my problem? I want to investigate the impact of height and weight on age. Age is my dependent variable and height and weight is my dependent. So I have two independent variables. So for that, I am using the multiple linear regression. Now, model summary represent from model summary what I would require to interpret. First one is the R and the second value is the R square. So R value is 0.349. So there is a relationship, but it is a very low positive degree of correlation exists between dependent and independent variable. The R square value shows only a 12% variation, or only the 12% variation is explained by in the dependent variable age can be explained by the independent variable height and weight. So again, our model, whatever R square we are getting, it is only 12% explained. So that means it is not good that much. From ANOVA table, you can see the p value. What is the p value? 0.558. 0.5 means it is a
Greater than 5%, 95% interval.
it is greater than, okay, it is already written here, it is greater than 0.05, and it indicates that null hypothesis is failed to reject because our p value is 0.558. Hence, the regression model is not statistically significant. So the model is not at all good fit for the data. So there is no impact of height and weight on age. So whatever data we have, from that data, the model is not fit. We cannot predict the age on the basis of height and weight. Understood? So the model is saying like that. Now how can we predict? So for that we have this kind of table, the coefficient table, from which we can find out the age. So here the equation is y is equal to a plus bx1 plus cx2 plus dx. Here, what is my A? A is my intercept. What is the value of A? It is minus 31.806. What is my B value? My B value is minus 298. So here plus minus minus. So I have put minus 0.298 here into my independent variable 1. So my independent variable is weight plus 1.605. Here I am putting the height. Okay, I am assuming that the person's weight is, say for example, it is a 140 kg and the person height is again, it is in a 64. I don't know it is in a which format, but I am assuming here. So what answer I am getting? So if the person has a weight of 140 and height of 64, then his or her age is 29. That means there is something wrong. It is not accurately predicting the age. Understood?
Yes.
So the model is not fit. That means something is wrong. Now what is that something that we have to find out? So for that, this is the steps which I have already written down in here. So the major problem is the multicollinearity in the regression analysis. Multicollinearity occurs when independent variables in a regression model are correlated, and this correlation is a problem because independent variables could be independent. If the degree of correlation between variables is high enough, it can cause problems when you fit the model and interpret the results. So whenever you run this kind of model, and if you found that your model is not fit, the first thing you have to check that do your model met the assumptions. So first you have to check the multicollinearity. So key goal of regression analysis is to isolate the relationship between each independent variable and the dependent variable. The interpretation of a regression coefficient is that it represents the mean change in the dependent variable for one unit change in an independent variable. And when you hold all the other independent variables constant, it becomes difficult for the model to estimate the relationship between each independent variable and the dependent variable independently because the independent variable tend to change in a unison. So how can you find the multicollinearity in SPSS? So for that, we have an option of multicollinearity. So the first thing is the correlation. If high correlation among the predictor independent variable exists, then you have to understand that there is a problem of multicollinearity. So whatever your independent variable are, you have to check the correlation of that independent variable. Then we have a tolerance value.
So, ma'am, if we ma'am, can I ask a question?
Yes, yes.
So it means that when before finding out the correlation among independent variables, we can't say it's multicollinearity, right?
Yes. Whenever you run the the regression analysis, and if you found that your model is not fit, so in that case you can find out all these options. First you have to run the regression analysis. It is advisable to check all the assumption first, but if you are not finding out your model is not fit, then you can again find it out, is there any options of is there any problem of multicollinearity or not. How can we check multicollinearity? I am explaining that. So first, how can you know there is a multicollinearity? So by doing correlation also you can know the multicollinearity. But for which variables you have to check the correlation? For your independent variables only. You have to check, click
I
on
will.
all the independent variable, and you have to check the correlation of that variable only. If you found the relationship between those variables, then you can say the relationship are there. Okay. Then
Yeah,
we
got it.
have
Thank you.
again the second is the tolerance value. By calculating this tolerance value, you can also know that if it is a less than 0.1, then multicollinearity exists, and then we have another value, that is the variance inflation factors. Now VIF, if it is a greater than 5, then there is a multicollinearity exists. So VIF start at 1, have no upper limit. A value of 1 indicate that there is a no correlation between the independent variables and any others. VIF 1 to 5 suggests that there is a moderate correlation, but it is not severe enough to warrant corrective measures. So if you get the values between 1 to 5, in the range 1 to 5, then there is a moderate correlation. So you can run the regression analysis. But if you found that you are getting value greater than 5, then there is a critical level of multicollinearity under which you cannot calculate the regression analysis. And if you calculate the regression analysis, whatever model you are making, whatever model you are predicting, it gives you the wrong values. So in this case, in our height and weight case, it gives a wrong value. It is not correctly predicting. Understood?
Yes.
Clear? So how can we find it in SPSS? So go to analyze tab, regression, linear regression. The same are there. In the statistics, you can see here we have a collinearity diagnostic. So you have to click on that collinearity diagnosis, then continue, and then click on OK. You will again find out the values. Okay. So what values you are getting here? For weight and for height.
For weight minus 2.96, minus 0.296.
Yes,
R value.
simply you have to check these values only. Okay. In this coefficient, you can find out the collinearity statistics.
Mhm.
So here you are
Tolerance
finding
to-
out the tolerance and the
Yes,
VIF value.
Yes, VIF value.
In this coefficient table. Okay.
All
So what is
VIF
my
values
VIF
are
value?
greater than 5. Greater than 5.
It is 5.695. So it is greater than 5. That means there is a collinearity, multicollinearity between weight and height. Now, why this happen? Why this happen?
Error of data error.
Yes, definitely the data error. Here you can see that my weight is in also again in a number, and my height is again also in a number. So in which number? So SPSS is a statistics. No, it is a software. So the weight is again measuring in a same number 62, as well as the weight we also measuring in the same numbers like 115.
Considering same.
Yes, if the values are different, then definitely the problem was not. And whatever, because generally you can find out that our age is definitely dependent on our height and weight. Na, is it true or not?
Ma'am?
Is it true that weight and